This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. We are going to find the exact value of the tangent of 157.5 degrees using the half-angle identities for sine and cosine, and then the identity that the tangent of A equals the sine of A over the cosine of A. All right, so we're trying to find the tangent of 157.5 degrees, but we're not using the half-angle identity for tangent. First, we're going to realize that the tangent of an angle is the same thing as the sine of that angle, so the sine of 157.5 degrees in this case, over the cosine of 157.5 degrees. Now 175.5 degrees is not a special angle, so we would have to use a half-angle identity for sine and a half-angle identity for cosine. This is part C in a series where we are finding the sine of 157.5 degrees, the cosine of 157.5 degrees. And so this third one, the tangent, we can fill in the values we got for the sine and cosine. So quickly, let's look up at how we did those problems. All right, in part A, we computed the sine of 157.5 degrees using the half-angle identity for sine. And so the result was that the sine of 157.5 degrees was the square root of 2 minus root 2 all over 2. And then in part B, we used the half-angle identity for cosine to compute the cosine of 157.5 degrees, and we got that the cosine of 157.5 degrees was negative root 2 plus root 2 over 2. So now we're going to take and write the sine of 157.5 degrees divided by the cosine of 157.5 degrees using these values. All right, so we begin with the tangent of 157.5 degrees is the same as the sine of that angle divided by the cosine of the angle, and now we're putting in our exact values that we already computed, and now we have a complex fraction. So again, you could deal with this in more than one way. I do it by multiplying the whole, numerator by the denominator. So I'm going to take the whole numerator, by the least common denominator, which is 2. And what does that give me? Well, this 2, I'm having problems with this. Okay, so when I multiply 2 by the whole numerator, the 2, it cancels with this 2 in the denominator, so I simply am going to get this numerator of square root of 2 minus root 2. And in the denominator, same thing, but I still have that minus sign. So remember that minus sign still there, negative square roots of 2 plus square roots of 2. Okay, well, now this is an irrational denominator. So now I have to get rid of the irrational denominator by multiplying by the conjugate. Or there's two ways of doing it, but I'm going to get rid of that minus sign by multiplying the numerator and denominator by a negative square roots of 2 plus square roots of 2. So I had this square roots of 2 minus square roots of 2 in the numerator, and I had this negative square roots of 2 plus square roots of 2 in the denominator. And another way of doing this is simply just putting the minus sign up in front of the fraction bar. Okay, that's probably even easier. So I want to multiply the denominator. This is like a square root of 5 or something, but unfortunately, instead of a little 5 underneath that square root, it is this whole thing, square root of 2 plus square root of 2. So I'm not multiplying by the conjugate, I'm multiplying that by the square root of what's in the denominator. I said that wrong a minute ago. And the same thing in the numerator. So now what does that give me in the numerator? Well, I've got a square root times a square root, so the whole thing's going to be the square root of those two things multiplied by each other. And in the denominator, I'm multiplying by the exact same thing, so I get what's inside the radical, right? It's just like the square root of 3 times square root of 3 is 3. The square root of 2 plus root 2 times the square root of 2 plus root 2 is simply 2 plus root 2. There's a lot of algebra going on here. You're going to be really careful. So, and I have that minus sign in front still, right? I didn't leave much room for that. So there's still a minus sign out in front. And now, what's that give me in the numerator? Underneath the square root, if I multiply that, this ends up being a difference of two squares because the inner and outer terms will be the same, opposites. So 4 minus 2 is what I get in the numerator, right? 2 times 2 minus square root of 2 times square root of 2. But now in the denominator, I have an irrational number still. Here's where I multiply by the conjugate. So I need to multiply now numerator and denominator by 2 minus square root of 2. So in the denominator, what are you going to get since you multiply by the conjugate? And I forgot, I keep wanting to put that minus sign out in front of the fraction bar. I have 4 minus 2, awesome. 4 minus 2 is going to just be 2. Everybody okay with that? Now, when you see square root of 4 minus 2, you could also simplify that. Square root of 4 minus 2 is the same thing as square root of 2, right? Okay, so let's just write this as square root of 2 to make it a little bit simpler. And now I've got to distribute the square root of 2 in the numerator. So square root of 2 times 2 is 2 square roots of 2. I'm going to keep this in parentheses, 2 square roots of 2. And then square root of 2 times negative square roots of 2, that's going to be a minus plain old 2. Okay. And now we need to simplify that. We could factor out a 2 out of the numerator here. And when I do that, I'm just going to write my minus sign up in the numerator. So I'm going to factor out a 2 out of the parentheses up there. So I have a negative, factor out a 2, square root of 2 minus 1 all over 2. These 2's will cancel, but remember, this is still a negative 1. So in the end, I get the opposite of square root of 2, so negative square roots of 2 plus 1, or you could write that as 1 minus square root of 2. So doing it this way requires a lot of algebra to get the answer. We're going to find the exact value of tangent of 157.5 degrees using the three formulas for the half angle identities for tangent of x over 2, and we will get the same answer. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.